Hi, everybody. Good afternoon. Today is Monday, first week of term, and I'm Greg Jackson. I'm your instructor this term. I probably have met many of you, some of you maybe not, but I just want to do a real quick intro to this week to make sure you all get off on a good start. And so I'm just going to kind of briefly go over some of the content and hopefully it may clear up some questions that some of you have before they come up. So, obviously, this is an introduction to Python. You probably have all already messed with Python, I hope, in CIS 122. If not, then this will be brand new to you. But if you already had 122 or any other course that required the use of Python, you've probably already gone through the installation of the development environment, the IDE, setting up Python itself, and setting up either PyCharm or another editor. We do use PyCharm and we refer to PyCharm quite a bit in this course. However, as an instructor, I will personally tell you that if you decide to use a different editor or IDE, I'm okay with that. In fact, a lot of the times in my videos, you're probably going to catch me using Microsoft Visual Studio Code because that's what I use most often. Sometimes PyCharm frustrates me, but PyCharm is a good tool. It's very widely used in the industry, so I'm not saying it's bad. I just prefer Visual Studio Code. But anyway, for what it's worth. So the content that we talk about this week is Python programming at a high level. Python is a phenomenal programming language. It is by far the favorite language I've used in my entire career. It was made from the ground up to be very easy to use, to be very intuitive, to be English-like, and to be incredibly powerful. And the inventor of Python absolutely crushed it. Okay, so Python has a very simple syntax. Python has most of the features of traditional programming languages, so you can use Python to learn a lot of different concepts and skills, such as object-oriented programming, etc. Functional programming is another one. Python supports the development of a wide range of programs, including games, web-based applications, administrative tools, batch scripts, etc. Python is used by, I'm not even going to say many successful companies. I would be willing to bet you couldn't go out and find a company today where somebody's not using Python, okay, for some purpose. That's absolutely the case where I work. I now work at Standard Insurance, and we're using Python all over the place, okay? Our primary application development language is Java, but you still see Python used all over the place. As a result, because Python is so commonly used and so high in demand, it's a very valuable skill and there's a huge market for it. So if you get really good at Python, chances are you'll have a pretty easy time finding work. Okay. The other really nice thing about Python is it's free. It's open source, totally free. You don't have to spend a single penny to have Python. One thing that confuses people is the difference between Python, the actual programming environment or the language itself, and the text editor or the IDE that you use, which again, in our case, is PyCharm. PyCharm is not Python. Okay. PyCharm is a third party editor, just like Microsoft Word is another text editor, right? PyCharm is a text editor that is specifically made for building Python applications. So it has all kinds of cool tools and bells and whistles built into it that helps you and assists you with coding Python and building Python apps. Okay. It is not Python. So if I tell you Python is free and then you say, wait a minute, I'm paying this money for PyCharm Professional. I thought you said Python is free. Python is free. PyCharm, at least the professional edition, is not. Microsoft Visual Studio Code is free, by the way. So just for what it's worth. Anyway, Python itself is free. Okay. Um, Python compiles and runs source code. So what happens is you will type the code in a text editor. And in fact, I'll even show you here in a minute. You can use any text editor you want, even Microsoft Word if you're crazy enough to want to do that. It'll work. Okay. So as long as you have some text editor, you can create Python files. You just have to name them with a .py extension. So just be careful with that. Once you write the code in your text editor and you save it to the disk, you'll actually run Python and you will tell Python, when I run you, I want you to go look at this text file named, myjunk.py. So run and go look at this text file and just execute all of the programming um, instructions that are in that text editor from top to bottom, okay, in sequential order. So what happens is Python will read or parse your file and it will read a line and then it'll take that line and it will interpret it. Okay. What that means is it will convert it so that the operating system knows what to do. So there's this intermediary between Python and the operating system that's called the interpreter. So the interpreter will read the Python code and will turn it into operating system code so your computer knows what to do. That process is known as interpretation. Okay. So the interpretation, when that happens, it's basically taking your Python code and turning it into machine code or literally ones and zeros. Okay. So that's what's happening. Python does that one line at a time while it reads the file. Okay. So Python is an interpreted language, is what that means. Okay. And you see that here. Other programming languages such as Java, or Microsoft C Sharp. They are not interpreted languages. They are what are called compiled languages, where you take your code that you wrote in Java or in C Sharp, all of this code, you still write it in a text editor, just like you do with Python. You write your code, write your code, write your code in a text editor. And instead of sending it to a converter literally at the time when you're running it, you send it to what's called a compiler ahead of time. And you tell the compiler, hey, look at this text file, and I don't want you to interpret it and run it right now. What I want you to do is I want you to compile it. And what compiling is it takes all of that code and turns it all into ones and zeros ahead of time and turns that into an exe file, an executable file. That way, later on, when you actually run the exe, all of the interpretation has been done ahead of time. And what that means to us is code written and pre-compiled in that manner is going to run faster than code that is being interpreted literally one line at a time as it's running. Okay. So that's the difference. Interpreted code versus compiled code. For us, typically, that is trivial because computers are so freaking fast today. 30 years ago, when I was getting my bachelor's degree, okay, that would have been a big deal. Having interpreted code when I was writing in COBOL, yes, I actually literally, my bachelor's degree, I was learning COBOL, which I never used for 1 minute in my career. But that's okay. So if I were to take COBOL code that I had written and tried interpreting it one line at a time while we were running on these slow old mainframe computers, there is no way in the hell the code would have ever worked. We had to pre-compile it. Otherwise, it would have been so slow, it would have been literally unusable. Okay. So these interpreted languages, such as Python and others, are able to handle very powerful commands today and tasks because our computers are so freaking fast. Even a cell phone and code running on a cell phone today is way faster than was on a mainframe in the 80s. Okay. So, having said that, if you need to write a program that absolutely 100% has to be screaming fast for some reason, maybe something like a heart monitor or an EKG system or um, probably air traffic control systems and missile guidance systems and things like that, where I mean you can't even have a millisecond of hesitation. Video games are another really big one. When you have motion video games, right? You can't really have hesitation in a real world game, because that hesitation kind of causes staggering in the UI and makes people motion sick and things like that. So for those types of applications, probably Python is not the best choice. Okay. You would probably want to go with a compiled language, such as, again, today the most common is C Sharp and Java. Okay. That's all I'm going to say on that topic. If you have questions, ping me. Um, Testing and errors. You are going to have to learn how to test your code. Okay. You're going to have to learn what errors to look for and to test for and to make sure are not happening. There are three categories of errors that you need to account for. The first errors are really easy to find. These are syntax errors. In fact, let me do this really quickly. Let me just show you really quickly how I'm going to create a program. I'm going to open this in Notepad. And I'm doing this in Notepad just to prove to you that I can create a Python application in any text editor. My computer's hanging. By the way, I've been having a horrible time with my laptop the past couple of weeks. So we'll see if the sucker recovers. If not, I might just smash it with a bat on live video. Ah, there it goes. Lucky. Okay, let's do new window. Okay. There we go. So this is a brand new file, and I'm just going to say um, print, quote, hello world. This is totally valid Python code right there, which I'm getting my cart ahead of my horse. But since you guys have had CIS 122 before, this is probably nothing completely new. I'm going to save this. I'm going to say File, Save As. I'm going to go out here on my machine. I'm just going to call this nothing. And I'm going to call this nothing.py. Notice my text editor, Notepad, is still trying to save this as a .txt file. So if I hit save right now, the file's name is going to be nothing.py.txt. I don't want it to put a txt on the end, so I have to go change this file type as all files. There. Now it will not try to glue a .txt file name on the end. It will just be called nothing.py. It is in my local disk in the users folder. This is my username. This is my work laptop, so that's why my username is so weird. I have a folder called Git and a folder called nothing. Okay, so nothing.py, and I hit save. Okay, now what I'm going to do is I'm going to open a command line. I hope you guys can see this. I hope. Guess we're going to find out. And on the command line, I'm in C users S00819. I'm going to go cd git, and I'm going to say cd nothing, and I'm in the nothing folder. So I do a dir, and sure enough, here's my file, nothing.py. Okay, so the file is in there. We all know it just says print hello world. So what I was saying is now I run Python, and I say, Python, I want you to run. By the way, you guys would say something like this, Python nothing.py. Okay. On my machine, I have to say py, and I got my machine monkeyed up a little bit. So I'll just say .py, and it goes out and it runs, and look at that. Hello world spits out on the screen. That's what I told it to do. It works perfectly. Okay. The reason I'm showing you this is I'm showing you I don't need PyCharm. PyCharm's a nice to have. It is not a must have. I'm using Notepad. That's a text editor. I said any text editor will work. It absolutely will. Now, to be fair, trying to write real world applications with just Notepad probably will be fairly laborious, but we'll talk about that a little bit more as we go. Now, back to syntax errors. A syntax error is an error where the code you are typing, the Python instructions, don't make sense. You're not even using a Python keyword or term that it recognizes, and it looks at the syntax that you've typed in, and it says, "I have no clue what you mean. I don't even know what you're talking about," and the code literally blows up, which sounds dramatic, but it's actually really good because let's say I had a typo. Boink, point, hello world. I'm going to hit fail. I'm going to hit save. There. Now, this is wrong. There is no keyword, not that I'm aware of, in Python that says point, hello world. So that Python's going to get confused. At least it should. So I go back into here and I just run python.nothing.py again. And look, it literally blows sky high. I get all this red, terrifying error messages on my screen, and it says, "Oh my God, name error, name point is not defined. Did you mean print?" So actually, Python is smart enough to even know what it probably thinks you meant. But the point is, this is a syntax error. It literally blows sky high, right? There is absolutely no ambiguity. We know for a fact something's very, very wrong. That's what typically happens with syntax errors, which is good because you can go in and fix it. You know something is broken, and I just go fix that and I run it again and it works again. Okay, no big deal. That's a syntax error. Yes, you definitely have to test for those. The easiest way to test for those is go run your code. And if your code runs without blowing sky high, you're probably pretty good with regards to syntax errors. Now, oftentimes, a syntax error, if you are in an IDE that is specifically made for Python, in your IDE, while you type in here, if I were to type point hello world, as soon as I hit enter, if I was in PyCharm or even in Visual Studio Code, if I told Visual Studio Code we were using Python, as soon as I hit enter, it would look at this literally while I'm typing and it would say, I don't know what that is. So you would get a syntax error. It would probably put a red squiggly line under the word point right there, even before I've even tried to run it, even before I've tried to save it. You get that real time. So syntax errors, again, you get a lot of feedback, immediate feedback that something's wrong, and that's great. Okay. A runtime error is an error that does not happen until the application runs because you didn't violate a syntax rule. The syntax technically is correct. You used the correct Python language constructs. You used the correct Python terminology and command set, so on and so forth. However, at runtime, something became very unhappy and it also will blow up. Okay, which is again really good. You want it to blow up. What are some examples of something at runtime where, I mean, the syntax is right, but then why is it not working? Well, divide by zero error is the most easy example. Dividing x by y syntactically is correct. But if x is a number and y is zero, it's going to blow up, right? So Python has no way of knowing what x and y are going to be until runtime. Okay. So I can come in here and I can say something like this. I'll fix this. So this is now print hello world. That'll fix. And I'll say, x equals 23, y equals 1. And I'll say print x divided by y, something like that. Again, really easy. And I'll convert this to a string str just so I don't get any weird numeric string conversion problems and trying to print. Technically, this should work. 23 divided by 1, that's not going to fail, I don't think. So I come in and whoops, CLS, clear that screen, and I run it again and I get hello world and I get 23. It is working. Okay. I have no syntax errors. And so far, I have no runtime errors. But what happens if somehow at runtime, some idiot assigned the value 0 to this y? Okay. The syntax is still correct. There's nothing syntactically wrong with this line of code, but it is going to fail and in beautiful fashion here. So I run it. And there we go. We get all this squiggly, like, oh my God, something horrible happened. And again, all this error message code looks terrifying, but it tells you literally what went wrong. It says, hey, there's a division by zero error. And it even tells you, the line that failed. This x divided by y is blowing up. So y must be zero. Oh, okay. I meant to say 10. Sorry about that. And I hit file save. And I go run this again. CLR, CLS, sorry. And now it's 2.3. Okay, so now we're working again. I was like, oh, that was my bad. That was supposed to be a 10. Okay, so syntax errors absolutely blow sky high, which is good. Runtime errors also blow sky high, which is great. Logical errors do neither. A logical error is where there's no syntax error, so the syntax is totally valid. There's no runtime error. So the code that actually runs produces some output. Okay. However, there's some weird logical error to where the output that you're expecting is wrong. You get something that you didn't anticipate getting. And these can be hugely problematic because no error message is happening and you may not even know it's a problem. The classic example of this is from the movie Office Space, where the idiots were trying to hack the frickin' payroll system with a rounding error that threw a penny in an account like once every 1,000 transactions, and the guy had a huge rounding error, so it was like doing a penny for every transaction or whatever the hell it was. The syntax error in his example, there was no syntax error. The runtime error, there was no runtime error. It was doing the math just fine. The logic was wrong. So logically, he had a very huge problem. Okay. I'm not going to demonstrate that in my stupid example because I think you get it. The problem with logical errors is they are not throwing errors. The Python application is not blowing up sky high. It's just running and it's happy as can be. It doesn't even know there's an error. The only way you're going to know there's an error is when your user says, hey, something's wrong in production and we're sending out checks that are inaccurate, and then crap hits the fan, and it's all hands on deck. Everybody's on a Zoom call trying to figure out what the hell's going on and why you're sending out checks that are wrong. Those are really bad days, especially when you don't find out until about 4:47 p.m. On a Friday. Okay. All right. So those are the types of errors. The goal of debugging is to find and fix errors before it gets to production. If you have an error and it makes it into production, fixing it and finding it is hundreds of times harder and more expensive. For example, if you don't fix the rounding error until after it goes to production, we've already sent out checks that are wrong. Our reputation is at stake, not just us as programmers, but the company, right, is at stake. We risk losing customers. We risk losing a lot of money. We risk lawsuit. I mean, all kinds of crap can happen. So you do not want errors to go to prod. Okay. So you need to create a test plan. You should read over this and talk about what is in a test plan. Here's an example of a test plan, coming up with all the use cases or all the scenarios you can possibly think of, including edge cases. So you don't just want to create test cases that are serving stuff up on a silver platter, like, well, if my user happens to type in 4 and then my user is lucky enough to type in a 2 and they hit enter, everything should be great, right? And then you run it and you say, it worked perfectly. See, my program's perfect. No, you want to account for unexpected inputs. You want to account for edge cases, large numbers, small numbers, negative numbers, zero numbers, non-numeric numbers, right? All kinds of stuff. And you want your test cases to be as exhaustive as you can possibly think. The more exhaustive you can have for your test plan, the better. Okay. So, anyway, that's all I have for that item. I'm not going to go into setting up Python or PyCharm. I'm not going to talk about using the debugger. We'll probably talk about that a little bit more later on in class. But that's all I have for right now. I hope you guys have a good week. If you need anything or have questions, please let me know. I am around, and I hope you all have a good week and enjoy the class. Thanks.